topics that we are going to discuss. Let's start with it. First of all, we are going to start with the basics of programming. So we all know about OS operating system. We all are using the different operating system, Windows, Mac, Linux, and all. So we are going to start our discussion from there. So the first question I have is, why do we need OS? And why do we need the different programming languages? Any answer? Anyone would like to answer these two questions? Okay. So the system and application request. Okay, great. So operating system is basically, OS is the operating system we have. We have different operating systems. Okay. And operating systems are used to handle the resources on our system. Okay. So why we are getting into the operating system? Are we going to get the details of the operating system, or are we going to get into the details of the OS concept? No. So this is just the what is exactly OS is doing here into the programming or the programming language. What is the role of the operating system, different operating system we have. So that things we are going to discuss, and that's it. So see, first of all, if you run any Python program or any program, basically it is an application, right? It is a Python application. So when you are executing it, OS will consider, your operating system will consider it as an application, and it will run program as an application like it runs the other application. Okay, so you have other applications, like if you will see, I have the image viewer, or if I have the PDF viewer, I have the Jupyter Notebook, I have the Google Chrome, this Zoom meeting terminal. These all are the different applications I have on my system, and these all applications are currently running on my system. So the operating system, how these applications will be running on my these applications, how these applications will be running on my system, that is decided by the OS. Basically, when I'm talking about the resources, so we need to understand that what all resources we have. So the resources we have on our system that has to be allocated to the different applications are, like you have memory is one resource, we have CPU as another resource, we have IO devices as another resource. Okay, then we have networking devices, these all are the another resource. Okay, so these all are the different resources we have on our system, and these resources has to be allocated. Let's say if you are running 10 applications on your system, so all these 10 applications cannot access, like one of your application cannot access whole of your memory, or it cannot block the whole of your memory, right? Or it cannot block the CPU for the entire process till it gets executed, because in that case your system will be the kind of system which can run only one program at a time. Okay, so in that case you have to wait to run the other application, correct? So instead of that, what we have multi processors, and we can run multiple processes or multiple applications on the same system at a time. So how does it work? So how these resources has to be allocated? Let's say if I'm typing something here, so it is getting typed on this screen, right, on this Jupyter Notebook. Why it is not getting typed anywhere else? Because you currently my input device is connected to this Jupyter Notebook, and all the input which I'm writing, currently CPU is guiding all the input to this particular screen. And when I'm able to see, this is coming to the monitor as the default output. So if I want to guide this output to somewhere else, I can do that also. So where I want to guide, let's say if I want to print something, okay, so I have to guide this output to that printer or USB port, right, wherever the printer is connected. So in that case, what will happen? So you are managing the resource, right, and that resource management is done with the help of the operating system only. Okay, so in general, when I'm talking, so operating system is quite important, is one of the most important part. And if you want to run any application, you need one operating system. And we also say that operating system is an interface between user and user and computer devices. Okay, fine. So you can interact with your system or with your hardware device using the operating system. So operating system is a system software. Okay. is what is the need of the programming language. Different programming languages we have. Okay, so what is the need of it having the programming language? So see, if you want to do any task, basically we can solve our problem using the computer, right? Let's say if you want to do some calculation, you are stuck in some calculation, you can take the help of the calculator. If you want to store some data, or if you want to play some video, you have, that is a problem in hand to you, right? So you can use some video player, or if you want to edit something into a file, or you want to maintain the data, so you need a kind of data maintenance application where you can maintain the data. Okay, if you want to browse something over the internet, that is again a problem, so you have a browser application. So like to do the different tasks on the computer or on the system, we have the different application, and these applications has to be developed using some programming language. So what we can understand, so indirectly I can say that to solve the problem in our hand, and or programming languages are required to get our task done from the system, right? Task done, right? So how we will be doing those tasks? With the help of the application, and to develop those application, we need a programming language. If you have a programming language, you can develop an application and you can get your tasks done. So you can develop a calculator application, or you can develop a browsing application, or you can develop a meeting applications like Zoom and all, or you can design a PDF viewer or image viewer or anything, right? So you have a programming language, and then using programming language, you can solve your problems. Okay. Not only this, okay, so this is the, you can say there are different other uses also. So we're not going to get into the details that what is the exact use of operating system or how operating system works. Yes, if you want, there is a good book on operating system that is written by Galvin. So you can get that book and you can read the details of the operating system and programming language also. So we are going to learn programming language right now, and we'll see that what all tasks we can do with the programming language. Okay. Now, the types will be coming to the types of programming language. What all different types of programming language we have? The different types of programming languages we have are low-level programming language, low-level programming language, and number two, high-level programming language. Okay, so what are low-level programming languages we have? We have machine language, that is also called binary language. Why we say that is the binary language? Because it is written in only in terms of 0 and 1. Okay, there is assembly language also, that is also a kind of low-level language which is used to do the hardware coding language. Okay, then we have high-level programming languages like we have C or C++ or C Sharp, right? We have Java, we have Python, okay? We have JavaScript, JS basically, we have PHP, okay? So these all are the different programming languages, high-level programming languages and low-level programming languages we have. As of now, we gathered here to learn about Python programming language, or the Python, which is a high-level programming language. So the first question that should come to your mind is why we are learning high-level programming language, why we are not learning low-level programming language, okay? So low-level programming language, we can learn it, but there are a few problems into it, okay? So low-level programming languages, what is the low-level programming language? Machine language or assembly language? What I said just now, that why do we need programming language? We need the programming languages to get our tasks done, or in other words, to develop the application. Let's say if you are going to develop an application into the low-level programming language, how that application will look like. So how that code will look like, the code which you will be writing. So the low-level programming languages, as I said, let's say if you'll be taking the example of machine language, that is written in terms of 0 and 1. That is written in terms of only 0 and 1. Now, let's say if you are saying here, you have to just write one line of code, A is equal to 10. Then how you are going to write it into the machine language? Okay, so to write this code, just one line of code, let's see how much calculation you have to do. First of all, you have to refer a table called ASCII table. Okay, what is this ASCII or Unicode table? Just go ahead and Google it out. What is this ASCII and Unicode? If you will look for it on the internet, you will find that almost all the characters which you have in your on your keyboard, these all characters are represented here in the form of table, and all these characters are having a respective decimal equivalent numbers. Okay, so you have 0 to 127, total 128 characters you have, and all the character, whether it is upper arrow, down arrow, space, equal to, plus, minus, multiplication, special character, A to Z, capital, small, underscore, everything is included in it, and every character is mapped to a decimal value. Okay, so first of all, if you want to write this code into the binary, then you have to refer to the ASCII table. You have to get the decimal equivalent first of all. So just think of it, you are in a world where you don't have these computers, simple computer also, and you are writing the code into the machine language, low level programming language. So you don't have the complex systems. You have the normal system where you have to write everything into the low level programming language, machine language. So you have to do the task of the computer by yourself. Okay, so you'll be converting this A to the binary. How you can convert this A to the binary? So to convert this A to the binary, you'll be getting the equivalent code of this A, that is 97, ASCII equivalent. Okay, now to get the binary equivalent out of it, you will keep on dividing this 97 by 2. You will be getting a quotient here. Let's say it is 48 and the remainder will be 1. Now you will bring this quotient to this position, and again you will be dividing it by 2, and then whatever remainder will be getting it here. So you will continue this process until you get 0 in place of quotient. So 24 by 2, you will be getting here 12. This is 48 only, right? 96, yes. So 12, then this will be 0. Then bring 12 here, divided by 2, you will get 6, 0. Then 6 by 2, this is 3, 0. 3 by 2, this is 1 and 1. And then 1 divided by 2, 0 and 1. So what I can say that if you just want to write A, to get the binary code, you have to come from bottom to top. So 1 1 0 0 0 0 1. So this is the binary equivalent of or machine code of A. Okay. Now similarly, equal to can be written into the binary as 61. Into the decimal equivalent is into the ASCII table. Equal to is equivalent to 61. So you'll be dividing this 61 by 2. Here you'll get 30, here you'll get 1, then 30 by 2, here you'll get 15, and result will be 0. Divide 15 by 2, you'll get 7, and then 1. Divide 7 by 2, you'll get 3, and then 1. Then 3 by 2, you'll get 1 and 1, and then 1 by 2, you'll get 0 and 1. So basically, this is the equivalent code for 61. So you'll be writing here 1 1 1 1 0 1. This is the equivalent binary equivalent code for equal to. And then what is 10? So 10 is 1 0 1 0. Okay. Now let's see this. So if you just want to write this A is equal to 10 into binary, okay, so you have to write first 1 1 0 0 0 0 and what was that? 0 0 0 and then 1, right? Okay, 1. And then for equal to, you have to write 1 1 1 1 and 0 1. And then for 10, you have to write 1 0 1 0. So this is one line of code you have written. Okay. Now do the same thing for B is equal to 20, C is equal to A plus B, and print C. Okay. So this code, just to do this kind of task, you will take hours. And let's say if you make some mistakes, so it will be really tough to find where exactly you have done the mistake. Okay. So maintenance will be tougher. Development will be tougher. It will be time-taking process to just write the source code for any application, right? And you cannot write the complex application like nowadays. We don't have this kind of applications, right? We have the kind of applications where we have to, those are kind of complex applications. Let's say if you talk about Facebook, or if you talk about Google, or if you talk about YouTube, these all are the complex applications we have, right? LinkedIn, these all are the complex applications you have. And the program is written for all those things. So one cannot imagine at all to develop these applications into the binary language. Okay, it will take years, probably the life of a lot of peoples, and then also will not be able to finalize what exactly the code is for this. Okay, so that is going to be quite complex, and hence this is the reason we don't follow the low-level programming languages, because of a lot of loopholes into it. First of all, the problem, not loopholes, but you can say these all are the problems we will be facing. First of all, the development time will be a lot. Then source code that will be getting that's kind of not finalized, whether if you have written the code, you can understand probably, but for others to understand, they have to do the whole process again. Okay. Third thing, it is not easy to maintain that kind of code, not easy to manage. And if some error comes, you have to go through the whole code again and again. And one more important problem we have is these all are you know not portable. They are neither portable nor platform independent. Low level programming languages are neither portable and not platform independent. Now, so think of that, let's say Facebook is an organization and is developing the Facebook application for every system in this world. Okay, writing the source code for every system in this world. Is that possible? No. So that's not the convenient way to do that. Rather than we have to write, okay, so what is the problem? Problem is from the user side. Okay, it is perfect if you'll be writing this code for this system. If you'll be giving this system will be rather happy to execute this code, and it will be taking very less time, because in this case your system does not have to do the translation. What is the system? System is basically a few hardware components you have, and these all hardware components are made up of electronic devices, right? All are the electronic components, and these electronic components, they understand only the signals, and signals is what? So only the digital signals, either 0 or 1. Okay, it means when you are writing that code, it means you are just giving the a language to a person which language it can understand. But instead of that, when you are coding into the high level language, this is the, let's say, electronic devices, and if you are giving it into the high level programming language, then this system has to do some conversion task or translation task here from high level to low level, so that it can execute those instructions, because your system can never understand the high level programming language. Okay, yes, but if you're coding it into the low level programming language, your system will be more happier to execute it, and the processing time will also be less. Okay, the processing time it will take, that will also be very less, quite less. Fine, everyone. So you understood the problem in the low level programming language. Any question? Discussed why we can't use low level programming language. So let's see. Next question is, okay, so if we are using high level programming languages, okay, so we have different programming languages. Why we are learning Python only? Why we are not learning any other programming languages like C or C++ or C# or Java? These are the different programming languages available into the market. Why we are learning Python only? Why not other programming language? So yes, you can learn other programming language for learning purpose. If you want to you can just go ahead and learn any of these programming languages. And remember, learning the first programming language is always the tougher task. But once you learn one programming language, learning the other programming languages will be very easy. Okay, so doesn't matter whatever programming. If that is true, if anyone who is coming from other programming background, they guys will find it easier to understand Python. Python is way easier than any other programming language, what I have felt. So you'll find that Python is quite easy, and you will love to code into Python. Okay, syntaxes are very simple and everything. But apart from that, there are many more features why we are learning Python. Let's have a look at those features as well. So the first feature we have for the Python is, number one, Python is simple and easy to understand. And it is expressive language. Okay, expressive means from looking at the code, you'll be able, once you look at the code, you'll be able to understand what exactly you are doing. It doesn't have lots of keyword which just jumbles your mind, and you will not be able to understand, okay, so what exactly, for what purpose we are using this keyword, or this particular word, for what purpose we are using. No. So to the point, what you want to do, only those things you will be writing in Python, and that's it. Your task is done. You are not going to get into the details of the other things, right? So that is the advantage of the Python. And simple and easy to understand means the syntaxes you will find in Python, that is quite simple. They are as easy as like writing the English language or writing the mathematical expressions. Okay, that is very simple, and hence it is easy to understand also. Okay, since it is simple, so anyone who is coming from programming background, non-programming background, doesn't matter. One can easily learn this programming language and understand it. Even see, it is no one can give you the guarantee that within just 1 month you can become a hard coder. No. Yes, but yes, one guarantee we can give from this particular class is that after this class, at least given any Python code, you will be able to understand that Python code. Okay, so this is what the purpose of this. And next, that if you have done that, that is more than enough. Okay, because if you'll be able to understand the programs, if any program is given and if you are able to understand it, at least you know something, and then you can explore the things into it. Okay, you can make some changes, and accordingly you can, so you'll be making some meaningful changes, not not those changes which you are not understanding. So it happens like when we give the assignment. So first time a person who is coming to the programming, they just try writing something, and if they get the output, it's fine, but if they don't get the output, they get stuck there, and then they try making some unnecessary changes which is not required. So they'll be bothered about whether if I'm giving a space, it is going to make some changes, or if I'm removing this equal to sign, will it make some changes. So those all are the changes which are not directed. You have to make some directed changes, and that you will be able to do only when you understand the code. Okay, so that part is quite easy in Python. Okay, so let's have a look at a few programs or a few sample code in other programming languages. So I'll be giving you the code to add Java code to add, or Java program to add two numbers. Okay, so let's have a look at it. What is the Java program we have? This is just a sample code I'm taking. Okay, it's not like you have to understand this code, what exactly it is happening here, but you just need to you need to compare it, Java code for adding two numbers. So you can see this is the Java code we have. Using this code, we can add two numbers. Okay, and at the same time, if you'll be looking at the Python code where you want to add two numbers, then let's see this how it looks like. So instead of Java, we'll be taking one Python code. So you want to add two numbers, just take two numbers into variables, b is equal to 20 and then c is equal to a plus b and print c. Okay, isn't this quite simple than the program which is written above? Okay, it is easier to understand also. It looks like I have written three mathematical expression and one print statement to print some value, right? This is quite simple compared to this, where if a person is coming from non-programming background, lot of doubt he might be having that, okay, what is this keyword, what is public, what is class, why we are writing this class, then why we are writing all these statements, what is this int and all, then what is this system.out.println and all. So these are things we have to explain before getting into the before writing our first Java program. Okay, and believe me or not, but if you'll be getting into the class and object concept, that is kind of painful for a person who is coming from non-programming background. Okay, so if you are coming from non-programming background and the first class you are going to get acquainted with this class method, class and objects, then that creates a lot of problem. Anyway, it's not for everyone, but few people. Okay, so we are just this is one of the reason we are doing the coding into the Python. Okay, it is simple, it is easy to understand. So why not Java, or why not other programming language? We have few other programming languages also currently available into the market. We are better than Python, or they are simpler than Python, but we are not using them. So this is not the only reason that Python is simple and easy to understand, but there are many more reasons which keeps an upper hand for the Python compared to the other programming languages. Okay, this is one of the reasons. So you can think of a situation nowadays. We know that whether you are coming from technical background, or if you are working into the technical profile or not, at least you should know one programming language. Coming days, those who are into the non-technical profile and not knowing the programming language, probably it will be very tougher to survive into the market. Okay, so it is a recommendation for everyone to learn at least one programming language. And if you are going to start your career into the programming, why don't you start with the Python directly, because it is easier for you. Okay, and also why this is required, or why this is mandatory, or why this is going to be mandatory, is because it's fine, we can hire a coder and he can do the coding, but he may not have the domain knowledge. But think of a person who is working into the industry from past 15 years, having enormous knowledge into a particular domain, right? So we can use his knowledge and experience in terms of coding, and then we can bring the unimaginable result from those experiences, right? So kind of AI and the ML applications which will be developing, so that requires the experience into a particular field, right? So that's the reason Python is quite demanding as of now. Probably in future, some language will replace it, but as of now, it is the Python which is currently ruling the market. Okay. This is one of the reasons. Second reason, let's have a look at it. So the second reason is Python is a general purpose programming language. When we say Python is a general purpose programming language, what do you mean by this? So general purpose means it can be used in any field to develop any kind of application, to do any kind of task. For example, let's say if you want to do application development like game app development, or let's say if you want to do web app development, or if you want to do desktop app development, you can, or you want to do ML or AI application development. Okay. What else you have? Let's say if you want to develop embedded or IoT applications. Okay. So you have Python. Let's say if you want to do the data analysis, okay, or in data science field, you can use Python. So almost every field, whatever field you name it, Python is there. Yes, there is one more field also, like mobile development, where Python is still not up to the mark. But yes, development is going on. Probably into the future, in few coming months or coming years, we'll be able to see the use of Python into the mobile application developments also. Okay, so as of now, apart from mobile application development, name the field, you have the Python there, you can apply the Python there. Automation, testing, everywhere. Okay, whatever fields you have, everywhere the Python is applicable. Okay, any question till here?
No.
Now, so the next advantage is number 3, Python is high level programming language. Python is high level programming language. So one can say, okay, so Java is also a high level programming language, but why we are not using it? Yes, Java is also a high level programming language. Python is also a high level programming language. But apart from high level programming language, Python has lots of advantages apart from this. Okay. Yeah. So when I'm saying high level programming language, actually I'm comparing Python with the low level programming languages. So security wise, Python is more secure and memory management is completely automatic in Python. This is one of the reasons we say Python is high level programming language. So when I'm saying high level, actually it is related to the memory management and security features. Okay, fine. So for this reason, we say Python is high level programming language and it is more acceptable. So if you will compare this same Python with the C, okay, C programming language, or C or C++. So in these programming languages, they are also the high level programming languages. But in the case of C and C++, as a user, you have to do the memory management. Okay, so you have the functions which can allocate the memory or which can deallocate the memory, and that creates a lot of mess sometimes. So that memory management feature is automatic in Python, and security features when it comes. So to do the coding, like if you go to low level programming language, if you are coding on a hardware device using some low level programming language, in that case, you should know the architecture of the system. So your system is not secure, right? So if, let's say if you have to make this program, low level program, understand someone, then you have to make them understand your system architecture also, which is not the correct thing to do, right? So you are making your security vulnerable to others, right? In other way, like if you'll be coming to the high level programming languages, they are considered to be secure because they are platform independent, they are portable. So you can just give them the source code or bytecode, they will be able to execute it, and they don't have to know these, system architecture of your device or your hardware or your system. Okay, fine, everyone. Fine, everyone. Any question?
No question.
No. So next feature we have for the Python is interpreter programming language. Okay, and when we say Python is interpreter programming language, somewhere you find Python is runtime also. Okay, what do you mean by runtime? So runtime means, remember, there is a term which you should remember, that is memory allocation and type checking. Okay, so wherever this task is completed or wherever this task is achieved, okay, whether it is at compile time or runtime, accordingly we can decide whether that programming language is a compiled language or a runtime language. Okay, so Python is a runtime language because these things happens at the runtime or the interpretation time. Okay, now let's see what do I mean by Python is interpreted programming language. So does it mean that Python does not have the compiler? So before that, going into the details of interpreter, let's discuss what is the compiler and what is the interpreter. Okay, so we know one thing, that we are going to code into the high level programming languages, right? You have this system, and this system cannot understand the high level programming language. If you'll say hello to this, it will say, okay, so what you are saying I cannot understand. Okay, so what you have to do is you have to and also you cannot you cannot sit and do the coding into the low level programming language for your system, right? That is going to take a lot of time. You are comfortable in writing the high level programming language, or you are comfortable writing the English words and letters, okay, but your system cannot understand it. So what we have, we need to have a translator in between them, which can translate this high level code to the low level code to this system. Okay, fine. So we will be having a translator which will be translating this high level code to the low level code to this system, and then system will be executing that code. These translators are of two types. One is compiler and one is interpreter. Okay, now this compiler and interpreter, the way they work, it is different, but the task of both of them is same. Okay, so what happens in the case of compiler? Let's say if you have written a code, so the code which you write, that is called the source code. Okay, fine. And when you give it to a compiler, let's say this is the compiler you have. So if you give it to the compiler, this compiler takes this whole source code and converts it to one intermediate code, or we can say executable code. It will be converting it to the executable code, okay, or some intermediate code. Now, how this compiler works? So this will be taking this whole source code at once, okay, and then it will be translating it to the executable code or the intermediate code. Okay, so compiler takes the whole source code at once, remember. Okay, whereas what happens into the interpreter? Interpreter does the same thing, but a bit in a different way. So what happens? Let's say you have written the code. In the case of interpreter, when you use the interpreter, so the code you write, that is called the script. Okay, now you will be giving this to the interpreter. Let's say you have this interpreter. So this interpreter will execute this code line by line, and it gives you the output. Okay, so in this case, interpreter will be generating the executable code or the intermediate code. We can say that basically the machine code. Okay, okay. Now what happens? So this interpreter will take one instruction at a time from this script. Okay, it will be executing it and giving you the machine code. Then it will be taking the second line, interpreting it, and will be giving you the machine code. Then third line, interpreting it, and then executing, giving you the third line. Okay, taking fourth line, interpreter, and then executing and giving you the fourth line, and so on. So basically it takes one line at a time from the script, execute it, and gives you the machine code, and then every line by line it will be giving you the outputs. So output for the first line, then output for the second line, then output for the third line. So first it takes one line, interpret, gives the machine code, execute, give you the first line. Then second line, interpret, gives you the machine code, execute, and give you the second line. Then interpret the third line, give the machine code, and execute, and get the third line output. Okay, so basically it executes line by line, and hence it is called the file which you are taking here, that is called, it is reading line by line, that's why it is called a script. And here it is taking the whole code at once, it is called the source code in the case of compiler. So now let's see how. So I hope you guys have understood what is the compiler, what is interpreter, what is source code, what is script. Okay, and translator, we have discussed that these translator are of two types. So Python has the interpreter, right? Now, so let's see first how a Python code gets executed. How a Python code gets executed. Okay, so first of all, you will be having the source code into the Python. Let's say this is the source code. Okay, then you will be having a compiler. This compiler, after compiling the source code, it is going to create the bytecode. Okay, now this bytecode will be given to one interpreter. This interpreter has the, like this PVM has this interpreter. PVM stands for Python virtual machine. Okay, now this interpreter, the output of this interpreter will be the machine code. Okay, and this machine code will then be interacting with your hardware devices or hardware components, and finally you'll be getting the output. So this is basically, we say, the whole flow of a Python program. Okay, now you can see there is a compiler and there is an interpreter, but still we say interpreter programming language. Why? Because remember I said there are two things. One is memory allocation and type checking. Okay, so these two things are done at the interpretation stage only in the case of Python. That's why we say it is the interpreter programming language. So what this compiler is doing here, so compiler, it checks for the compile time error in your source code. If you have any compile time error, then bytecode will not be generated. And if you have no compile time error in your source code, then only the bytecode will be generated. Now, this bytecode will be taken instruction by your interpreter, and it creates the machine code that in turn creates you the output. Clear? So this is the whole execution sequence of a Python code. Clear, everyone? This is the intermediate code or the executable code, which I was saying. Okay. Now, let's see what happens here. Error. Okay, let's have a discussion on the error. So there are mainly two types of error. One is compile time error, and another is the runtime error. So in the compile time error, we have syntax error, we have indentation error. Okay, and in the runtime error, we have name error, we have type error, we have value error, etc. Okay, now what is the syntax error? See, when you write a program, syntax is basically, we say it is the rule, okay, that we have to follow to write a Python program. So Python is a program and some rules are defined. Whenever you write a Python program, that rule you have to follow. For example, when you are writing an assignment statement, variable should be written on the left hand side and value should be written on the right hand side. There should be one equal to, and then executing, giving you the third line. Okay, taking fourth line, interpreter, and then executing and giving you the fourth line, and so on. So basically it takes one line at a time from the script, execute it and gives you the machine code, and then every line by line it will be giving you the outputs. So output for the first line, then output for the second line, then output for the third line. So first it takes one line, interpret, gives the machine code, execute, give you the first line. Then second line, interpret, gives you the machine code, execute and give you the second line. Then interpret the third line, give the machine code and execute and get the third line output. Okay, so basically it executes line by line, and hence it is called the file which you are taking here, that is called, it is reading line by line, that's why it is called a script. And here it is taking the whole code at once, it is called the source code in the case of compiler. Clear, everyone? Source code and script is clear, compiler and interpreter is clear. Any question from anyone?
So Abhishek, in C and C++, we know that once we compile, there is some hex file or binary file created that is called executable file, right?
Yes.
So in Python, I didn't see that kind of file. So is it directly executing or something?
Yes, we will be looking at it. Okay, we'll be coming to that in some time. Okay.
Okay.
Fine. So now let's see how. So I hope you guys have understood what is the compiler, what is interpreter, what is source code, what is script. Okay. And translator, we have discussed that these translator are of two types. So Python has the interpreter, right? Now, so let's see first how a Python code gets executed. How a Python code gets executed. Okay, so first of all, you will be having the source code into the Python. Let's say this is the source code. Okay, then you will be having a compiler. This compiler, after compiling the source code, it is going to create the bytecode. Okay, now this bytecode will be given to one interpreter. This interpreter has the, like this PVM has this interpreter. PVM stands for Python virtual machine. Okay, now this interpreter, the output of this interpreter will be the machine code. Okay, and this machine code will then be interacting with your hardware devices or hardware components, and finally you'll be getting the output. So this is basically, we say, the whole flow of a Python program. Okay, now you can see there is a compiler and there is an interpreter, but still we say interpreter programming language. Why? Because remember I said there are two things. One is memory allocation and type checking. Okay, so these two things are done at the interpretation stage only in the case of Python. That's why we say it is the interpreter programming language. So what this compiler is doing here, so compiler, it checks for the compile time error in your source code. If you have any compile time error, then bytecode will not be generated. And if you have no compile time error in your source code, then only the bytecode will be generated. Now, this bytecode will be taken instruction by your interpreter, and it creates the machine code that in turn creates you the output. Clear? So this is the whole execution sequence of a Python code. Clear, everyone? Fine. Any question? Okay.
Hi, Abhishek.
Yes.
In C++, exe is generated like that. When Python, what is generated?
This bytecode that we say .pyc file.
Okay.
Okay. This is the intermediate code or the executable code which I was saying. Okay. Fine. Okay. Now let's see what happens here. Error. Okay. Let's have a discussion on the error. So there are mainly two types of error. One is compile time error, and another is the runtime error. So in the compile time error, we have syntax error, we have indentation error. Okay. And in the runtime error, we have name error, we have type error, we have value error, etc. Okay. Now, what is the syntax error? See, when you write a program, syntax is basically, we say it is the rule, okay, that we have to follow to write a Python program. So Python is a program and some rules are defined. Whenever you write a Python program, that rule you have to follow. For example, when you are writing an assignment statement, variable should be written on the left hand side and value should be written on the right hand side. There should be one equal to sign. You cannot have equal to here. That will be giving you the error. Okay. When A has some value, then you can probably compare it. Okay. Then B is equal to 20, C is equal to A plus B, and then print C. If you'll be looking at this code, so this is the syntax which we have to follow. Let's say if any one of these things you are missing, let's say if you have not written this thing, so it will be giving you the syntax error. Or let's say if you have missed this equal to sign, so it will be giving you the syntax error. So these all are the syntaxes that we have to follow, and we cannot miss those syntaxes. Missing those syntaxes or missing those rules will be giving you the syntax error. There is an indentation error also. So indentation error is basically the space, unnecessary space in your program. Okay, so if you will be giving unnecessary spaces in your program, or if you'll be missing the spaces which is where it is required, then it will be giving you the error. For example, let's say if you are writing one if statement, after if statement you have to write one condition that will be evaluated as true. So I'm just writing true, and after true I have to give a space. So whenever you write this kind of statement where you have to give a colon at the end, so it is expecting a space to create a block. So we will be writing hello. Okay, something we have written here. So now this statement will be executed. If you have not given the space here, then it will be giving you the error. Okay, that is called the indentation error. Let's have a look at this two errors. So this is the code, it is giving me the output, but let's say if I'll be missing this bracket, it is going to give me the syntax error. Okay, unexpected UF file passing. Similarly, let's say if you are going to miss this one, so this is going to give you the syntax error. Why? Because there is a equal to sign should be accepted, or something should be written. It cannot be written like this. So there is some rule for that. We should follow those rules. Okay, so this all comes under the syntax error, and there is an indentation error also. So for example, let's say if you will be, this is the syntax error. Let's say if you want to see the indentation error, so in the case of indentation error, unnecessary spaces. For example, if you're giving some space here, so this is an unnecessary space, and if you'll be executing it, it will be giving you the indentation error. Okay, so if you are giving some unnecessary spaces in your code, then it will be giving you the indentation error. Don't do that. And this is it about the compile time error. So your compiler checks for these kinds of error when you execute the Python code at the compilation stage. Okay, only the compile time error. Now, if there is no compile time error in your source code, remember, if there is no compile time error in your source code, then it will be taking the whole source code at once. It will compile it, and then it will be creating the bytecode out of it. Okay, so there should not be any compile time error to create the bytecode. If you have any compile time error, your bytecode will not be generated. Clear, everyone?
Yeah.
Okay. Next, what we have? Next, we have interpreter. So what this interpreter does, it will take line by line. Okay, so if I have any runtime error into the code, then will it be executed? Will it be compiling the source code? No. Sorry, yes, it will be having any runtime error, it will be compiling it. So let's see the runtime error. What runtime error we have discussed? We have discussed a few errors, like let's say if you are trying to access a value which is not defined in your program, it will be giving you the name error. Okay, fine. Let's say if you have this program, and in this program you are trying to access the value of D. This D is not defined, so this will raise name error. Okay. Okay, let's say you have a function called int, and in that if you are passing a float value inside the quotation, it will be giving you the type error, because int cannot take a float value into the string format. Okay, similarly value error. So there are different types of value error. So there are different types of runtime error. If you want to have a look at all the runtime errors in Python, you can just go ahead and write here print dir double underscore built-ins double underscore execute it. You will be getting all these errors which you have in Python, including compile time and runtime error. All these error list you have here, starting from arithmetic error to zero division error. This is the error list in Python. Okay, you can have any of these errors in your Python program. Okay, so out of this, these two are, we have discussed, this syntax and indentation are the compile time error. Rest most of this will be coming into the runtime error, or the yes, runtime error. Okay, now if you will be having any runtime error in your Python code, your Python code will be compiled. But if you have compile time error, Python code will not be compiled. It will not be creating the bytecode. Remember this. There should not be any compile time error in your source code. Otherwise, it will not get compiled. And if you have runtime error, it will get compiled, because it is not the task of the compiler to check the runtime error. Okay, it is the task of your interpreter to check the runtime error. So if any runtime errors comes here into the bytecode, so your interpreter will stop executing then and there. So for example, let's say you have these many lines of code, some error comes at this line. So what interpreter will do, it will execute these 2 lines and then the further execution of the code will be stopped. It will not be executing. From here onwards, no code will be executed. Okay. Clear, everyone? Any question? The error is clear that if you have any compile time error, bytecode will not be created, and if you have runtime error, bytecode will be created. Okay. Okay, so now let's see that. So we have seen the Python is interpreted language. Why? Because the memory allocation and type checking is done at the runtime only or at the interpretation stage. That's why we say it is the interpreted programming language. Okay, and it interprets. So the execution of the code happens at the interpretation stage only. Okay, now let's see this. So let's see this bytecode and let's execute this source code to get the bytecode, and we'll be cross verifying it. Whether if we have any compile time error, bytecode is getting created or not, and if we have runtime error, whether the bytecode is getting created or not. If we have runtime error into the bytecode, then whether it is interpreting or not. Okay, so these all things we will be doing one by one. We'll be coming to that, Ravi. Wait. Okay, memory allocation. We are not discussing the memory allocation as of now. Okay, so to do this, to get the bytecode and all, we are going to get into the terminal. You guys don't have to do this, so just follow this and just try to understand the concept. That is the only thing you have to do. Rest all is, no one is going to ask you, and this much internal, no one will be asking you anywhere in the interview or anywhere. Okay, but yes, if you will understand this, so the concepts are important. If you understand this, probably you can visualize how the code is getting executed, and that will be easier for you. And in case that if you have the base strong, you can learn other programming language, because most of the programming languages follow the similar kind of structure. Yes, there will be a few minute differences that you can manage later. Okay, but let's understand how this works. So first of all, where we are into the this default location. I will be moving to the desktop, so I'll be going to cd space desktop, and I'll be creating one folder, f1.py. So vim f1.py I am creating. Okay, and this file is already existing. I'm going to I have written this code already. So now what I'm going to do is I'm just going to save this file and execute it. So as of now, is there any error into this code? No, right? So if you want to see the content, you can just check the content here. This is the content. Is there any compile time error or runtime error into the code? No. If you want, I can execute the code vim f1.py, and you will see that it is giving me the output. Now, just a second. Yeah. So you can see this is f1.py, and this f1.py is having this code. Okay, and if I will be executing it, then it should give me the bytecode, right? Are you guys able to see the bytecode? Okay, so this is the f1.py on my desktop, and there is no bytecode. I said that there will be .pyc file will be created, right? But I cannot see the .pyc file. So to see that .pyc file, see what we have to do. We have to do this process manually. We will be first compiling the source code. We will be only compiling this source code. After compilation, we will be creating the bytecode. So then we can see the bytecode. If I'm executing it directly, so what it does, it is creating the bytecode internally. After execution, that bytecode is deleted. Okay. So why? Because Python is interpreted programming language, so you don't have the explicit compilation step here. In programming languages like C and C++, it got disconnected. So if you will see this, I will be directly executing it. You can see I have written this code, and I'm going to click on run button. Okay. When you will be clicking on run button, it will be executing the code, and it will be giving you the output. Now inside this, if you will be seeing this, I'm not compiling it explicitly. Whereas in other programming languages, like in C or C++ or Java, you have to first compile the code, source code, and then you have to execute it. Okay. So, but in Python, this compilation is an implicit step. It creates the PYC file, and it loads into the RAM. It executes the instruction one by one, and then it gives you the output. And after that, once the execution completed, that bytecode is deleted from the RAM. But now what I'm going to do, I'm going to create that bytecode manually one by one. But before that, let me show you one runtime error. Okay, so I'm going to print D here, and I'm going to print A here. Okay, execute this. You will see that you are getting the output for print C, which is 30, but print D is an error. This name D is not defined in the code, so it is giving you the name error. Name D is not defined, and it is not giving you the output of print A also. Though print A is defined, but it is not giving the output of this. Why? Because program got the error here and it stopped the execution. So when I'm getting the output for print C, it means bytecode got created. Okay, intermediate code got created. While executing that, it saw that this line is not defined. So at runtime, it stopped the execution here, right? We are going to cross verify it in some time. Let's see that we have this code, and now we are going to compile it explicitly to see the bytecode. Okay, so the command to execute the file or compile the file, we have Python -m py underscore compile, and we have f1.py. Okay, now if you will be executing it, one bytecode will be generated, and that bytecode will be saved in the same location where you have saved your Python file. So you can see this f1.pyc, it just got created, and this is the content of the file, which is not understandable by the normal human beings, but it is easily understandable by your system or your computer. So next, we have seen the bytecode. So how we have created the bytecode? We have created by this command. Okay, so we have compiled the file as of now, and since there was no compile time error into the code, so it didn't give me any error, and also bytecode got created. And now how we can run this bytecode? So to run this bytecode, we can write Python f1.pyc run. So it will be giving you this. So now we are running f1.pyc, which is available on the desktop. So this f1.pyc is available on the desktop. That code we are running, and we are getting the output. Clear? Now, so let's do one thing. Let's make some compile time error into the source code and check whether it is generating the bytecode or not. Before that, I will be deleting this .pyc file so that that will not create any confusion. So now what I'm going to do, I'm going to open the Python file vim f1.py here, and then I'm going to make some syntax error. So the syntax error is, I'll be removing this bracket. Okay, this is the syntax error, escape :wq. Now let's compile this file. So when I'm trying to compile this file using this command, it will show me the syntax error. That syntax error is here, and if you will see here, the bytecode is also not generated, right? Okay, so what we can understand from here, that if you have any compile time error in your bytecode will not be generated, right? Now, let's see if we have any runtime error, can we generate the bytecode? So let's open this file again, and this is the content. So now we are going to make one runtime error. To make this runtime error, I'm going to print A first, and then I'll be printing D. This is the runtime error, and then I'll be printing B. Okay. Fine. Now, so see, according to the concepts which we have discussed, bytecode will be generated because there is no syntax error. Bytecode will be generated, but when I will be executing it, program execution will stop here, but it will be giving me the value of C and A. C is 30, A is 10. It will be giving me these two values, but for B, it will not be giving me the values, right? So let's see that. Let's cross verify it. Let's execute it. I'm going to compile this file. So let's compile it. I didn't get any error as of now. Let's come to the desktop. There is the f1.pyc created, correct? What does it mean? It means that if you have any compile time error, bytecode will not be generated. But if you have any runtime error, bytecode will be generated, right? Because compiler is not checking for the runtime error. Clear? Now, if I will be executing this bytecode, will it execute this bytecode? Let's see that. I'm going to open this Python f1.pyc. Okay, when I'm executing this compiled file, you can see I'm getting the output for line number 4 and 5, that is print C and print A, but I'm not getting for print B. Though print D is not defined, but I'm not getting from print B, right? So for print D, it is giving me the error, and the execution got stopped there itself. Fine. So this is how a Python file gets executed. Okay. Now Next, let's move to, so we have discussed these topics. We have discussed the compile time versus runtime error, source code, bytecode, machine code I have shown you. So source code is the code which you are writing. Bytecode is after compilation, the source code, bytecode gets created, machine code after interpreting the bytecode, machine code gets created. We have seen the different types of error. We have seen the compiler versus interpreter. And then we have also seen that how a Python program runs on our system. Let me know if you have any question. Otherwise, we'll be moving to the next topic, that is the memory management in Python. Okay, so now let's have a look at the memory management in Python. So memory management in Python refers to two terms. One is memory allocation and then memory deallocation. Okay, and remember this, both memory allocation and deallocation, that is memory management in Python, is automatic. Okay, so we as a user have no control over the memory management techniques in Python. That is taken care by the PVM. Okay, so it is PVM which manages the memory management in Python. Okay, fine. PVM, as I said, it stands for Python Virtual Machine. In other words, you can say PVM is the brain of your Python also. Okay, this is the only tool which manages all the objects which you have created and how the memory will be allocated, how much will be allocated, and all those things will be taken care by your PVM itself. Sorry. Okay, so there are a few more features we have to discuss. That is, okay, Python is portable and platform independent. Okay, Python is portable and platform independent. So what do you mean by portable and platform independent? So remember, whenever you talk about portability, okay, or if you say a programming language is portable, it means the source code which you are writing, this source code can be moved from one system or one platform to another. Okay, and when we talk about platform independent, so in this case, bytecode can be moved from one platform to another. Okay, fine. Now, which all programming languages are portable and platform independent? So if you will talk about low-level programming languages, they are neither portable nor platform independent. Okay, in the high-level programming languages also, in C, you can say it is portable, okay, but not platform independent. Okay, if you'll talk about C or C++ both, okay, if you'll talk about Java or Python, it is portable and platform independent both. Okay, fine. Now let's understand this. So what happens into this? So first of all, low-level programming languages which you are writing, so they are hardware specific, right? Written on one hardware cannot be moved to another hardware. That is very simple. Now, if you'll be coming to C or C++, okay? So we know one thing, what happens into the C or C++, let's say you have written this source code, okay? You compile this source code with the help of a compiler, and then you create one intermediate code that is called executable code, right? Or let's say you create one .exe file, okay? Now this .exe file, when you execute, this gives you the output. Okay, so the intermediate file or executable file that you are creating, if you have created it on Windows, you cannot run it on Mac. Okay, if you have created it on Windows, on Mac it will not be running. Fine. In the case of C programming language, if you have developed any application, so this will create a problem. Okay, whereas to counter this problem, we have came up with the Java platform independent languages. Like in Java and Python, what happens? First of all, we write the source code, we compile it with the help of a compiler, and with this compiler we create one platform independent code that we say bytecode or object code. In the case of Java, it is called object code. In the case of Python, it is called bytecode. And this will be then further given to the compiler or interpreter. Okay, that will be executing this bytecode or object code and will be creating the machine code. This machine code will be giving you the output upon execution. Okay, so this is how the Java and Python code are executed. So in case of Python and now, so in the case of Java, we use JVM here, or in case of Python, we use PVM here. Okay, so this course which you are executing, they are running on what? They are running on a virtual machine. They are not running on the operating system, or they are not running directly on the hardware, right? This machine code which you have created, that runs on the hardware and that gives you the output. Correct. So these intermediate code which you have generated, they are platform independent. Okay, this bytecode or object code are the platform independent. Why? Because they are running on a virtual machine. So they create, after getting executed by this virtual machine, they create one machine code that runs on your hardware. But when you will be coming to C, in the case of C, the executable file you are creating, that directly runs on your hardware, and then it gives you the output. So this is equivalent to your exe file is equivalent to machine code, and hence it is not portable. Okay, but if you will be coming here, it can run on any platform. So it is not platform independent, but this one is platform independent. When it comes to portable, so your Java code and Python code, this is the source code which you have written. So on any system where you have PVM or JVM installed, when you will be executing this source code, there'll be a compiler coming with it that will be creating the bytecode and object code. Okay, so you can move the source code also. So these codes or these programming languages are portable and platform independent both. But when you will be coming to C, in the case of C, you can move the source code from one platform to another. So it is portable, but you cannot move this intermediate code or the executable file to another platform. So it is not platform independent. Okay. So the next feature we have of the Python is number 6. Python is platform independent. Okay, when we say, sorry, not platform, Python is dynamically typed programming language. When we say Python is dynamically typed programming language, what does it mean? So you will find a number of programming languages. So there is a statically typed programming language. So first of all, let's understand what is statically typed programming language. So like C or C++ or Java, these all programming languages are the statically typed programming language. Okay, fine. So what happens in this case or in these programming languages is, when you are taking any variable, you have to specify the data type. Let's say if you are going to store the integer data into a variable, you have to specify the data type int a, then you have to write it. Or let's say if you have to keep a float value, then you have to specify the data type for that variable, and then you'll be keeping a float value. Okay, let's say if you are going to store the string value, then you'll be writing str of c is equal to, let's say, whatever the string you'll be writing inside it. Okay, now inside, if you'll be trying to write a string value, then that will be giving you the error. So this kind of restrictions we have, and up to an extent this restriction is fine, but it's fine. Like statically typed programming language has their own advantage and disadvantages. Similarly, dynamically typed programming languages are having their own advantage and disadvantage. We're not going to get into the detail, get into that discussion that which one is better, statically typed or dynamically typed. But yes, this is a feature of the programming language. And what advantage I look at in the dynamically typed programming languages, you don't have to bother about the syntaxes a lot. Okay, so you don't have to, in the beginning itself, you have to say, okay, so if I want to assign string, let's assign a string. Why I have to fix the data type? And if I want to assign some other value to this variable, let's assign that. Let's do that. Okay. But sometimes it creates a problem into the dynamically typed programming language. Anyway, we are not going to get into that discussion. But let's see what happens into the Python. So in Python, we have just seen one program that if you want to assign a is equal to 10, so you have just write a is equal to 10, and this type of a you will be checking, that will be giving you an integer value. And let's say after some time to the same variable, if you want to assign a string value, you can do that also in Python. So that makes that it is the dynamic programming language. Okay. Now, how this type is decided? So Python is going to execute the program sequentially, right? When this line will be executed, at that time, type of a will be decided that a by the PVM. Okay, type of a will be decided as integer type. Why? Because you are assigning an integer data to it, right? When this line will be executed, a is still in. But when this line will be executed, Python will see that, okay, you are assigning a string value to a. So the type of a will become string. Now it will change. Okay, fine. So this is the dynamically typed language. And in this case, you don't have to specify the data type. Now, what happens? Why we need to specify the data type into the statically typed programming language? Because you remember I said there was one term, memory allocation and type checking. Memory allocation and type checking. Okay, so this memory allocation and type checking is done at the compilation stage into the statically typed programming language. Okay, remember C, there is a compiler, right? There is a compiler, and then this creates the executable code, right? So at the compilation stage, this compiler should know that if you are using a variable, what is the data type of it? Because this compiler will assign some memory to this variable so that you can store some integer value and all. Okay, and actually because of this, you need to have the different type of integer data type. Like we have short, we have long, we have int, and all those things in other programming languages, in Java also. But in Python, this all things are done at the interpretation stage, right? So what happens when you write a source code, you compile it. So this compiler is not going to check the type, right? It will just checking the compile time error. But yes, your PVM, so this is the bytecode you have created, your PVM will be checking the type of the data. So a is equal to 10, which you have written. So it will be checking, okay, what is the data? It is 10. So it will be allocating the memory, some memory to it for a, right? Let's say 28 byte of memory it will be allocating based on the data. Okay. So actually PVM is considering any number, whether it is small or large, it will be considering everything as integer, and hence PVM is not much rich into its data type. It has everything considered as integer. Okay, sometimes it feels okay, Python is since memory management is automatic, and because of dynamically typed programming language, Python is taking much memory. But yes, you can say that is the loophole that is coming into the Python because of being dynamically typed and other features, having other features. Okay, whereas in other programming language, when you'll be going, so like see, when you store a value 10 into Python, it takes around 28 bytes of memory. Okay, whereas this same 10, if you'll be storing in C, then in C or Java, it will be taking only 2 bytes of memory. Storing 10 will take only 2 bytes of memory. So obviously memory is less, but that is, you can say, that's not a big issue nowadays, because memory, okay, so we can manage it. Okay, fine. Now the next feature we have in the Python is huge library support. Okay, so we have number of programming languages still available in the market, which are probably more easier than Python, but the library which has been developed in the Python over the time is huge. Okay, so there are few more languages which are more easier, or you can say they are equivalent to Python. But since we don't have much library support on those programming languages, so we are not using them. But probably in the future, when we'll be having enough library support for them, so we will be learning those also. Okay, but as of now, Python is quite rich in its library. Name it, whatever field you want to go, you have probably the library developed into it. Okay, so the advantage of it is you don't have to write the code from scratch for everything you are doing. So let's say if you want to develop a web application, you have the Django package available. You can just download, and the advanced parts like security features and all will be taken care by the that Django package itself. Okay, so there are lots of advantages of it, And then in like, let's say if you want to do the data analysis, so instead of creating the instead of writing the code on arrays manually, okay, you have the built-in library and packages and the functions available into the NumPy and Pandas, which you can use for doing the data analysis job. Okay, so you are not going to write the code from scratch. That is the biggest advantage in Python. Okay, and it comes with the batteries included. So that is an acronym basically, which says that the required module which you need while writing any program, those all modules comes by default into the Python when you install it. Like when you go to C, you have to include few header files and all. Similarly, into the Java also, you have to include few modules and all before writing your first line into the Java or C. But in Python, you don't have to do that. You simply come and start writing the code. The important things which are required, like if you want to use print statement or int function or some built-in function, those important functions are already included. Also, it comes whenever you download Python, there are a number of modules like math or census module gets downloaded with it. So you don't have to download it separately. If you want, you can directly import them and you can use them.